Hello, it's very nice to be here speaking on this very interesting topic of powering Industry 4.0 with purpose-built private networks. My name is Vinay Dhar, and I'm head of private networks business with MAVEdge. What I want to start with, of course, is setting the scene. We all know that private networks have existed for many decades in the form of monolithic and large macro networks supporting specific use cases, especially in the domain of security and public safety. But what we'll see now coming in the next few decades is a paradigm shift on private networks and driven by these following sort of four main macro trends. One is, of course, what we see is acceleration on spectrum democratization happening across the world. An example, Germany and Europe has been leading it with already 100 dedicated spectrums allocated to enterprises in band 3.7 to 3.8 gigahertz. We have CBRS in US, UK has band 77, Japan has band 79, and it's now accelerating across the globe, and enterprises now have a much higher empowerment to really have total control on the network, and with that, a total control on the data that's being transmitted on the network. Then, of course, you have on the other side the industry, which is on the customer side, the industry digitization, and it's also accelerating, especially from after pandemic. I mean, the need for digitization has only grown. Every industry is looking at digitization to drive operational efficiency, productivity gains, but also, placing themselves and preparing themselves for any disruption that will happen in the industry. And new use cases such as, in Industry 4.0, you have automated guided vehicles, AR, VR type, and also connecting to smart machines and robotics. I mean, those use cases are coming now. And that puts basically demands on network, and which are being a bit unfulfilled demands on the enterprise side of sort of catering with high reliability, mobility, ultra low latency, time deterministic network. And that really puts a big demand on private networks to support these use cases. Then on the technology side, I mean, distributed computing has evolved in the last 15 years, and you see what the impact it made on the consumer side with the over-the-top layers, and now we see same things happening on the enterprise side with sort of 5G being at the center of how the architecture is defined. From if you compare it with the previous G of 3GPP technology. 5G really brings distributed architecture at its core and helps basically to really adopt to the cloud native architecture, which really then, of course, simplifies and also helps in really driving the scale. And lastly, then you see a collective power of the ecosystem in play, where sort of there are industry associations that are defining requirements towards the 3GPP specification. First time in the history of 3GPP, there are ecosystem investments happening across device companies, application companies, industry players, system integrators, technology players, cloud players. That's really driving the investment into really what will happen within private networks over next decades or more. And then private network itself, I mean, it's not a single flavor. I mean, you have private networks on one end, which is driven by large, wide area, macro networks, which is what we've seen. And those are basically addressing the public safety type use cases. And then on the other end, you have fully isolated standalone networks where you have totally independent in how you design those networks and no interworking with the public network. And in the middle, then you have multiple options, with a public network, from the MNO, from an MNO to an enterprise with special SLAs to cater to a specific use cases, can further be sort of driven by actually providing a full end-to-end network slice with network resources dedicated and customized to a particular use case. Example could be providing a high data throughput type, end-to-end SLA with security, full isolation for a use case. And then you have two different variations of public network with local infrastructure, where you have basically the core coming from the public network, but then on the edge, you have fully dedicated radio access under SLA and probably under managed services to provide sort of full SLA-based approach and keeping, of course, in that case, keeping the data in the premise. And then standalone private networks also in a version where operator basically provides and manages the spectrum and leases the spectrum to the enterprise. So there are multiple variations. That's good because then you actually have flexibility and enterprises can choose which one of these flavors will cater to their requirements and their use cases. Then on the other hand, if you see the digital transformation, the center of the digital transformation is really getting visibility by connecting machines and connecting things and collecting data. And it's really basically taking that to the next level where then you bring the industries really drive transparency and use basically productivity analysis and adaptivity analysis to really cater to driving operational efficiencies or productivity efficiencies, or also in many cases driving disruption in the industry. And that's what we call basically a highly connected and a data-driven approach, where data-driven innovation is at the center of the business. That requires, of course, a network which basically goes across different tasks and across different segments of the business. Today, the scenario is quite fragmented. You have different technologies being used for different use cases. You have DECT, for instance, they're very voice-oriented, Wi-Fi which has worked very well for NBB and mobile data-based use cases. And then you have ultra-wideband networks which support precise positioning, especially if you want indoor positioning type use cases. And then in most cases, on the factory floor, for instance, 60 to 80% is still connected over our cable through Ethernet and dedicated LANs. That requires basically high security and high throughput, and that's what is supported via Profinet or Profibus in case of Industry 4.0 protocol, over the Ethernet for the PLCs to connect to the smart machines. And you have a scenario where it's very fragmented. Different types of network address different types of tasks and requirements. Hence, the big challenge is that there's no continuous information flow. There's no uniform or fast, flexible data processing. And that, of course, there is no real-time coordination to really drive an ambition of every industry to become a data-driven, innovation-oriented industry. And then what does 5G bring? I mean, and that's what the promise is of 5G. 5G for Industry 4.0 means that they actually have the ability for first time on a 3GPP network to address, each use cases that have different requirements, each task that have different demands on the network. 5G has that ability to really address and cope to those different demands. It could be for use case that requires enhanced broadband for speed and increased capacity. It could be a use case that requires ultra reliable and low latency communication. It can be a use case where you need to connect massive number of devices in a small footprint. It could also be for use cases where you require the intelligence to be at and computing to be at the edge for security purposes, or for also ultra low latency type of use cases, and also for time sensitive networks, which is one of the big demands for Industry 4.0 to cater to really this dream of having cable-less factory floor, and also in the end ability to run the entire solution on cloud infrastructure. And 5G brings this promise first time in any G of the 3GPP technology to cater to the enterprise and industry use cases, and also support for varied types of tasks and demands. And so in nutshell, what 5G really does, it connects the IT world to the OT technology of an industry, where you have seamless data transformation, from the IT world, which has been well connected and has been there for a long time. And then on the OT side, I mean, a heterogeneous network that basically connects and brings this promise of really driving data at the center of the business. And in that case that you see here on the slide, I mean, you have a 5G network which is connecting to the things and devices, could be machines, could be goods, could be sensors, could be handhelds. And then through the 5G network, which then connects to the RAN layer, from there to edge computing and 5G, and into the business application systems to really provide this end-to-end information flow. And in that case, then of course, driving the use case enablement, which could be, on one end, if you look at from the left upper corner here, providing basically the ability to do, condition monitoring of a machine, and then in future with smart algorithms to drive really predictive maintenance and predictive, anomaly detections to really drive operational efficiency. On the other hand, also, if you see a use case here, where in this case in AGV, which basically comes on the intersection, has to really slow down because, the risk is it can actually collide with people walking on the intersection. So today there's no intelligence there. And in the 5G network, you basically bring that intelligence through edge computing with ultra low latency. And in this case, then the AGV will move as fast as it can and not stop, just that it doesn't have that intelligence, and it drives efficiency. To basically what you see on the left corner down, the real sort of vision of a factory floor to become cable free, and providing the flexibility, of flexible layouts and everywhere access and control for, assembly lines to be changed, without any costs. Today, if you change a layout in a shop floor, it's a huge cost because it's all cabled. And then, for a very expensive machine like a robot, to basically, have flexibility to change position to address to certain tasks on the factory floor. So I mean, the use cases are varied. It varies from connecting simply, to get preventive maintenance to really fulfilling a dream of a factory floor to become a cable-free, based scenario. So what are we hearing from the industries in terms of what demands they have on the private network? One, I mean, they want it to be fully end-to-end solution for fastest TTM, which basically has scaled down, low footprint solution, has fully capability of full integration with the backend and the network assets, and has ability basically to do multitude of use cases. So the software functionality, they expect it to be, what is defined on 3GP in terms of addressing the varied sort of use cases. Could be, MBB or time sensitive use case, or a simple industrial IoT type use case connecting to massive number of devices. Then the second requirement is the complete architecture and deployment flexibility. This is where they want really the simplicity and the ability to manage with a single pane of glass, full automation, plug and play approach to really drive the operational costs down. And one of the challenges in the industry is that there is very limited competence of running these networks. It has been mostly on the macro network side, and the MNO competence has been built over the last 50 years. But when you actually deploy these network with enterprises, it needs to really, it needs to be done in a different approach. So automated installation, zero touch provisioning, all of that becomes a very important part of really defining the complete architecture. And lastly, then, a much more simple and predictable pricing. Most of these networks will be used to really drive internal efficiencies and internal productivity. And it's not that they will be used basically for selling, getting more revenue. So a pricing metrics, which is, more simple to follow, is predictive, is transparent, and ability to really drive innovation, which is aligned to their business requirements, becomes very key. So an end-to-end private network for Industry 4.0 basically has, as I said, I mean, previously, needs to be a complete end-to-end service offering. And the key thing is that it needs to address, for the openness and for the ecosystem to play, it needs to address a cloud native web scale approach end-to-end, starting from, the RAN layer, which needs to be virtual. It needs to be, it needs to adopt to an open interface. And then from there, edge compute layer and 5G core, all of that needs to be fully containerized and adhere to a cloud native design principle, supporting microservices and APIs. And for the simplicity of these networks, they need to have a central OSS and orchestration, integration possibility, fully automation, applying CI/CD approach. Should really be driving end-to-end approach in terms of openness for the ecosystem to participate. Should have the flexibility to be deployed in multiple ways, such as public, hybrid, or cloud, an enterprise network or an edge network. And in the end, I mean, what is very important is that these networks need to be plug and play and pre-configured and coming with an option of, option for managed services based approach. It needs to be very simple in order to really bring down the complexity and bring down the operational complexity of running these networks. At MAVEdge, we have this in our mind, and that's where we sort of bring the differentiation. I mean, in our sort of approach from end-to-end perspective, we follow a very open architecture, a cloud native architecture, right from RAN, which then of course is based on OpenRAN architecture, where you open up the interfaces to the third-party radio antenna suppliers to provide their radio antennas, integrating it on ORAN interface. In this case, in the slide you see on the front haul split 7.2 interface, and then on the DU and CU side you see being hosted as containerized functions running on a normal x86 hardware. And then on the core side, then you also have a fully containerized packet core with the management capability of sort of managing this full network end to end with a single glass of single glass pane of single interface end to end, and the automation of really deploying and managing these networks. So openness is key within our approach of sort of defining these networks, which we believe is very important for addressing the Industry 4.0 requirements. So my final slide, connected digitization is no rocket science. It's been happening now. It's accelerating in some of the industries. The key is to really think big, but I mean, start small. Data, this is complex. The key is that you start with small projects, and then of course the key is get connected and scale fast. I mean, digitization is happening at fast pace. Connectivity is an important enabler to drive that digitization, and we believe that private networks now for future, especially for Industry 4.0. Will come in multiple shapes and multiple forms, and the ability to really drive that flexibility, it would be key, and drive that openness in terms of ecosystem players to participate and drive innovation collectively will be key. That's the end of my presentation. Thanks so much. I've been very happy to be here, and I'm happy to take any questions that you have.